Okay, let's see the video about the GCP processing in the SLAMGOPOST. First, you need to prepare the data with the GCP collection during the file work. And here you can check the GCP collection and the number during the collection. The SN is the sum device number, and the data, and here is the number and the collect time, and the mark P means the control point, and the type is 1. P's number and the type 1 is the control point. Here I collect 20 control points. And then you need to prepare the GCP information. Here I prepare the 20 control points in one list at the txt format. You need to prepare it as this format is the number A001 and the east coordinates and the north coordinates and the elevation here. Please be careful. And then let's open this create of this project in the SLAMGOPOST. Date paste input and select here. Second two. Here you can see I have a empty project and without any mapping and any input. If you input the GCP here, and you can see we have some settings like projected coordinates and the local coordinates. Normally we need to select the corresponding coordinates in this list. For example, in this data is CGCS 2003 degree with 117E. And in the bottom we have the list in the control points. Click confirm. Here you can find if we click the edit control point, I can see the similar interface but without the reference control points and the matching control points. This is because we have no trajectory information and the control point information in the matching temporary data. Then you can process the one-click solve if you have the corresponding number. But if you not, you can create project first, like this. I created or optimized, it means the original mapping data. All of the after process is basing on the original coordinates or original point cloud. And for now, if we click the edit control points, we can see here we have the 20 reference control points and the matching control points in this interface. Here we can see you have the corresponding P1 and A001 and P2 A002. The matching point is that we see in the FM mark we have P1 and P2 P20, and the reference is the control point we import in the txt list. So here we see the reference and the matching coordinate system. We have 20, and before you process orientation, you had better check the control points one by one. Normally, if you don't have the matching number, like A001 is P1, A002 is P2, you need to check it one by one, like this. Check it if it's matching. And if you have some points you don't want to put them into the processing, you can set it as a checkpoint. Checkpoint means this point will only join the accuracy inspection, the result will not be affected by this point. Yeah. Or if you're not sure which point is correct, a line function is very useful. The line function will detect the different distance between the different points and match them together. After finish the settings, click Confirm and then process the orientation. Okay, before process the data, need to add the active the project and process. You can see here we have two settings with non-rigid orientation and rigid orientation. You will notice if you click the non-rigid orientation, the select list is in gray, and if you select the rigid, it will could be choice. This is because the rigid will only move and rotate the point cloud to be the absolute coordinate system, and if you use a non-rigid, the software will refer the GCP or RTK to process the data for reduce some cumulative error. So this is a useful settings if you use the data in the large scenes and some environments, maybe you have the large errors. Also in the orientation, we have the dynamic object filter functions here. After settings, you can click Confirm. After Confirm, we have this project. This project. And with the GCP, you can use the pick point to get the coordinates. And after process the data, you can see the report in this button. Here it includes some information like coordinate system and the orientation functions, type, and the orientation data source. Here is the accuracy. You will see the difference between the real world and on mapping. The accuracy is lower than 1 centimeters, and the ground control point accuracy here, and the accuracy with the checkpoints. Here you get the GCP here, and then you can process like the optimization and the texture. Of course, how to import the GCP with one-click solve. For example, I import the GCP here into the software, but we cannot see if it is matching or not. The only way we can put the GCP in the one-click solve is please be confirm the every point is in matching. For example, P1 match the A001 and P2 match the A002. For this, the software will, according to the number, match them first. If the first step is correct, so the software will start the orientation directly. Finish the orientation, it will optimization and process the next step. But if the number is not corresponding, maybe it will get the error in here. You need to check if it's correct and edit it, and then finish it by manual or reprocess the one-click solve. Okay, this is all about the GCP orientation here. And the latest step, here I have GCP. In the GCP, you will see here is the project. The project is similar with the SLAMGOPOST internal list and with some local benchmark is the relative position in the GCP point. Okay, this is all about the GCP orientations. Thank you for your watching.